Okay. Today we are going to learn something more about the polymers. In last class we have learned something, and today we would like to learn a little bit more about the polymers. And first of all, we would like to know what are the components are required to make different types of polymers, because we want to use different polymers in different purposes. So based on what purpose we are going to use, we need to add different types of additives. That means the process.
Professor?
Yes.
So today you are supposed to have our first quiz, right?
No, not today. Thursday.
Thursday.
Yes. We have changed into Thursday, is it? Thursday 6:30.
Thursday. Okay. Thank you, Professor.
Thursday 6:30. Okay. So we are going to learn how we can prepare, or based on what criteria. Here you can see different types of or different colors. We can make colorful all the, as we have different grays, we can have different types of polymers with different colors. Not only different colors, different properties. So based on what property we need, we will add different types of additives to the polymers so that it can change the property. Compounding is a process of melt blending plastics with other additives. That means you may have certain compound and you can change the property by adding some other ingredients. This process changes the physical, thermal, electrical, or aesthetic characteristics of the plastic. That means we can change the characteristics what we need, because sometimes you may need insulation. That means we are using different types of electric cables or any other types of internet cables. So if we want to use electric cables, then electricity pass through copper wire, is it? Then if you do not have a very good insulation over the wire, in that case just we will get into contact with the electricity and suddenly we can die. Therefore we need to make certain property for the polymer that it is very much or very good for insulation. So insulating material, we need to change the property of the polymer so that it can change into insulated material. So this process changes the physical, thermal. Some of the polymer material can be heated in very high temperature. Some of them can survive up to 3000 degrees Celsius. 3000. That means sometimes you can have the resin. You are familiar with the word resin? Some kind of glue which is used to attach some ceramic, or sometimes we have different types of glue, and this is very expensive. So maybe we can keep the temperature up to 3000 degrees Celsius or even up to this. So based on what property, why we need this, we will add. Sometimes you can have the gloves. That means in laboratory you use gloves. By using that one, you cannot hold any hot substances. But we have some special gloves that we can use to cook. That means it can keep the temperature insulated so that it's very easy to use, even up to 400 degree Fahrenheit, which corresponds to around more than 250 something like this degree Celsius. So even up to that temperature you can use the gloves. So based on what property we need, or expecting what kind of property from the material, we have to add different types of additives so that we can change the property. Okay. Ingredients used in compounding of plastics. What types of ingredients we can add to change the property? Fillers. Some word I will discuss all of them individually. Fillers, plasticizers, stabilizers, antioxidants, ultraviolet absorbers, and biological preservatives. So there are different types of materials we can use. Fillers, what are the fillers? These are organic or inorganic compounds added during compounding to increase the bulk of the polymer. That means if you want to increase the size of the polymer, in that case, you need to add these types of fillers. What are they? Wood, mica, clay, silica, talc, fabric scraps, glass fibers, carbon black, calcium carbonate. Any of them we can use for the fillers so that we can increase the size of the polymer material. So this is one of them, just to increase the size, that is the, or to increase the bulk. Therefore we can add these types of material to the polymeric compound. Then plasticizers. Maybe I should not show what is the plasticizers. You are familiar with the word plasticizer. Yeah. That means flexibility. If you have some flexible, if you want to have the flexible material, then you need to add some plasticizer. Is it? So let's see the substances which are added during compounding to increase the plasticity or flexibility of a polymer. So if you have some polymer which is not normally which is not flexible, but if you add some other materials like as esters, tricresol phosphate or triphenyl phosphate, diethyl phthalate, fatty acids, petroleum based oils, different things. So if you add these types of materials in the polymeric substance, then it can have the capacity to have the flexibility. So that even in the last class I have mentioned, just if you can understand the word, meaning of the word, then easily you can identify or understand what is what we are discussing. Stabilizer. Most of the time we use stabilizers in our home to protect different types of instruments like fridge or a computer or any other things. That means sometimes we may have different types of or the fluctuation of the voltage. That means if you have sometimes very high voltage, sometimes very low voltage, then your instrument can be damaged. Therefore, if you want to have a constant flow of the electricity, in that case you can use the stabilizer. Similarly, not exactly similarly, but something, polymers have tendency to undergo degradation by air and light. Normally, if you have a most of the time some girls use the rubber garter to tie the hair. But if you put the rubber for a couple of days or couple of weeks in the open space, just after a couple of weeks, you will see that it's just it becoming like as a solid. It loses the elasticity, or it will become something like this. Just it can melt easily. So, and if you have, you can have different types. Some of them little bit very hard, and some of them very soft. Those which one is very soft, it can damage quickly. Those who are hard, they can damage little bit longer time. So if you add some types of these types of material, phenyl salicylate, aryl alkyl phosphate, triphenyl phosphate, white lead chromate, in that case, it can increase the stability of the polymers. Therefore, polymers have the tendency to undergo degradation by air and light. The stabilizers are added to minimize the degradation. So, with the influence of light and air, That means if we say light, we are giving as an energy. In last few classes, we have mentioned about the light is nothing but energy. So if we give light, that means it will give some energy, and air we will consider. If you understand chemistry or biochemistry, then air is nothing but nitrogen, oxygen, and moisture. We will consider like this. So just 78% nitrogen, 21% oxygen. So when we ask you to write down the reaction of some chemicals with air, most of the time you need to write down the reaction of that chemical with oxygen. Is it? What major percent is nitrogen? However, nitrogen is mostly inert. Therefore, we do not consider. If you mention air, that means oxygen. So, if we can add these types of materials, that can increase the stability or minimize the degradation. Okay, then lubricants. Lubricants like waxes, oils, stearates, oleates, and soap are employed to make the molding of plastic lubricants, prevent the plastic material from striking to the fabricating equipment. So, when we synthesis or when we prepare the plastic material or the polymeric material, in that time, when we reduce the temperature, because we need to first we are melting the polymeric material to make a different type of shape. But if you change the temperature or reduce the temperature, it can easily make into hard, and it is not easy to transfer. So if you can add some lubricants, in that case it is easy to transfer. So when we are making the plasticizing materials or these types of materials, then we can add some lubricants so that it's easy to transfer. Then, if you want to make that types of colors, you can add different types of coloring agents. So what we can add? These are the added to impart required color to the polymer. We have different types of. You have red pen and another pen, different types of. So sometimes we have green, white, or whatever. So based on different color, what we are interested to see or what we need, we can add different types of coloring agents. So that would be colorants. These are added to impart required color to the polymer. This increases the attractive and decorativeness of the polymer. The colorants include organic and inorganic pigments. So, what types of color we want to see? Based on that, we will add the color. Antioxidants. Most organic polymers are subject to atmospheric oxidation. That means reaction with oxygen. Atmospheric oxidation. Particularly during hot processing, they are the most often stabilized by additives which retard the oxidative reactions. So, if you can add some materials which do not participate in the reaction between oxygen and that material, so just sometime we can add some catalyst for the reaction. So, if you can add catalyst, we can have two different types, positive catalyst and negative catalyst. But most of the case we consider catalyst as positive catalyst. And another one named as poison. Have you ever heard? That means mostly we call the negative catalyst as poison. So antioxidants will behave like as poison so that it will not help to oxidize. Ultraviolet absorbers. That means we can have different types of plastic materials or polymeric materials. So it can absorb. If the color is black, then it can absorb most of the radiations. Whatever the radiations, black, white, or red, whatever the color is coming on, in that case, it will be very easy to absorb. But if you can have some materials that absorb mostly the UV, that can be helpful for us, because we always try to avoid UV because it is very high energy. So if we have the material that can absorb the high energy radiation, that can be even helpful. So atmospheric oxidation of most polymers is accelerated by ultraviolet light from the sun. As already mentioned, that the energy of UV is very high compared to any other wavelength in the sun, but we have any other high energy, X-ray, gamma ray, but that is not the subject, because from sun mostly we get up to UV. Okay. Then, therefore, plastics for outdoor use are frequently established against ultraviolet light specifically. So, when we want to use the plastic materials or polymeric materials that should be used in the outside, so we need to have the ability for the material that it can absorb the UV, not reflect. If it reflects, then it can be dangerous for us. So we should have the capacity that it absorbs the UV light. The most common stabilizers are ultraviolet absorbers such as orthohydroxybenzophenol and orthohydroxyphenyl benzotriazoles. So these types of materials can be added. If you can remember just few of the names, maybe one for each of them, that can be very good. But it is not necessary to memorize all the examples, because all the informations are available in your book or in the internet. So just try to understand what are the functions. If you understand the name, then you can easily understand the functions. So try to understand that, and if you can remember one example for each, that would be fine. Okay. Now that can be same thing what we have mentioned about the ultraviolet absorbers and flame polymers, flame retardant additives. That means what I have mentioned, that if we want to cook and we want to hold the pan with the gloves, in that case, if we use the plastic gloves, that can catch fire even. Therefore, we cannot use that type. So we can use some gloves made of different types of silica. So we can use that types of polymer. So it can be used as a fire retardant. Flame retardant additives are divided into two basic types depending on the interaction of the additive and polymer. Here we have two different kinds, different types. The polymer itself can be fire retardant, or we can add some other ingredients to make it fire retardant. So there are two types. Just the polymer itself can be fire retardant, and we can add another ingredient, like as what we have mentioned about different types of this colorant, antioxidant, ultraviolet absorbers, or whatever. So we can change the property of the polymer by adding some ingredients. Okay, now here we have some examples. All of you are familiar with this one. This is packing material. When you purchase some fragile substance, anything, in that case, just we fill the box with this expanded polystyrene and then ship. This is very light, is it? Okay. So this is expanded polystyrene and normal polystyrene. That is plastic cup. Normally we call this is polystyrene. This is plastic cup. But it's not very good to drink hot drinks. You should not drink hot drinks in this types of cups, because most of the time when you put some hot drinks, in that case it can give some radiation that corresponds to carcinogenic. That means Carcinogenic, you are familiar with this word? Yes. Okay. Which produces cancer. Okay. So always try to avoid these types of cup to drink hot.
But let's say I saw like a plastic ball. They said that you can use for oven. Oven it heats, right?
Yeah.
What about that?
Okay. In case of oven, in last, maybe in the first or second class lecture, I have mentioned about that. You can use for the oven because it will not melt up. It will not melt because when you put into the microwave, it will heat up the water. So that is okay, but bowl not very hot, because if some water vapor or water moisture in the bowl, then it can absorb some of the light and it will not heat up too much. Just any drop of water it contains, then it can heat up. But as the material is insulated, it will not transfer heat from hot water to the bowl. Therefore, the bowl will not heat up too much. Yes.
Providing the substance, and we are just making tea in that substance. What about that?
Like this one?
Yeah, just like this one. Same
Okay.
What is your comment on that?
I would say if someone uses these types of cup to drink water, hot water or tea or coffee, whatever, just they are trying to save some money, and without they are trying to kill you.
No. I think that was not the exact class that you're talking about.
Okay.
That is kind of different.
You can have that good quality, but I suspect that they do not know about this, the quality. Yeah, they do not know the quality. Just they are using some cup to give you the coffee or tea. Just nothing else. They do not know even. Okay, so we have, this is nylon, this is PVC, and this is polyethylene. This is very soft one actually. Just most of the time we use one time. But we have some bucket made of hard plastic also that can be made of different types of PVC also. Okay, now we'll learn how we can synthesize some of this. Preparation, properties, and uses of polyethylene, polyphenyl chloride, graphite, epoxy resin. So we'll try to learn how we can synthesize some of these polymers and what are the uses. So let's go into preparation, properties, and uses of polyethylene. This can be obtained by the polymerization of ethylene, just polyethylene. You can see the name. Just remove the poly. This is our monomer, ethylene. So when hundreds of millions of ethylene molecules combine together, it forms polyethylene. So what are the reaction conditions? At very high pressure and temperature around 150 to 200. This is here very high pressure, 1500 atmosphere. Our atmospheric pressure is 1 atmosphere, is it? We are in the 1 atmosphere, but this pressure is very high, 1500 atmosphere. So when we use 1500 atmosphere pressure and 150 to 200 degree Celsius, okay, this zero should go as degree Celsius, not 2500. Okay, so in presence of traces of oxygen as a catalyst, just very small amount of oxygen should be used as catalyst. In that case, we will have lot of ethylene molecules will combine to form the polyethylene. If we use free radical, we can have two different types of mechanism. That means what types of polymer we should get out of the ethylene. Just if we use free radical initiator, in that case, low density polyethylene, LDPE. Okay, one very interesting thing I will show you, that the low density polyethylene LDPE, the density for these types of no, okay, LDPE has a density of 0.91 to 0.925 gram per cm cube. That means just little bit lower than water. What is the density of water? What? Again, please. Density of water. Don't get confused. This is very simple. 1 gram per cm cube. 1 gram per cm cube. So just little bit low compared to water. Okay. So if we use free radical initiator, that means we have the ethylene molecule and we are using these types of temperature and very high pressure. But if we use some free radical for the start, that means initiator, that means which helps to start the reaction or initiate the reaction. That is, if we use free radical initiator, then we can get LDPE. That means low density polyethylene. And if we use another types of reactor, next page will show you. So LDP has a density of 9.91 to 0.925 around this. Now my question is, we have some another types of polymer which is called HDPE, high density polyethylene. Now, what can be the density for high density polyethylene? I want to get the number, the value. This is our low density polyethylene, 0.91 to 0.925. Then you can guess how much the density should be for the high density polyethylene, that means HDPE. In next slide I have. Times 2? Anyone else? 0.9. No, already we have more than 0.9. So let's move to the next slide. Okay, nothing here. Just difference of 0.91 to 0.925, that was LDPE and HDPE. Only this difference. This is the difference in density. However, all the plastics or polyethylene have density lower than water. And even all the oils in the universe, whatever the oil, all of them have the density lower than water. Okay, so let's go back a little bit again. Now, if we use the free radical initiator, then we will get the LDPE, and this is the reaction. That means ethylene, benzoyl peroxide. This is our free radical initiator, and high pressure we are getting this polyethylene. What are the uses? It is used in the insulation of electricity carrying wires and manufacture of squeeze bottle. All of you are familiar? What is this squeeze bottle? Yeah, you can say. What is the squeeze bottle? Just when you take your sauce, tomato sauce, then you press the bottle. That means all the bottles cannot be pressed, but some of them can be pressed or squeezed so that it can get the high pressure and the tomato sauce can come out. So that types of bottles can be prepared using these types of LDPE. Then films, sheeting, and flexible pipes. That means as the structure for these types of materials are little bit. So this is flexible. A structure for these types of, that means LDPE, are flexible. Therefore, we can use as a squeezing bottles or some other sheeting films and flexible pipes. Yes. Film. What types of film? Just different types of plastic films. Sometimes you can have the grocery, when you go in some grocery shop, then you can see some plastic covers are given over the vegetable. Have you ever seen that types of film? This is very simple. What are the properties? It is a rigid, waxy white solid, translucent or transparent. It is permeable to many organic solvents. It crystallizes easily. So just if you heat little bit, it will melt up, and then if you remove the heat, it will crystallize automatically or very fast. By the use of ionic catalyst, previously we have mentioned, if we use the free radical initiator for the reaction, then we will get the LDPE, low density polymer, with the structure linear. That means the structure is flexible, but by the use of ionic catalyst results in the formation of high density polyethylene. So high density polyethylene we are using Ziegler-Natta catalyst and little bit low pressure. Okay, so if we use these types of catalyst, and then we can have the polyethylene, which is very hard, and that the density is little bit higher compared to the LDPE. So what are the density already have mentioned? 0.94 to 0.965, just little bit above. Okay, high density due to linear structure C below. Okay, I have done some mistake. That means here these are the branched, so not the linear structure, what I have mentioned by mistake. So this is the structure mostly. In that case, there will be some void if there is another chain after this, so there will be some open space, so that when many molecules combine together, in that case there will be some open space for the air. Therefore, it has the density little bit low. But for HDPE, these are linear, so therefore it's easy to come close. Therefore, the density increases. So very less amount of air can be inside. Therefore, the density becomes higher. Okay, now you see the use. I'm not interested to teach this. Okay, see the structure. This is HDPE, that means linear mostly, but this is our LDPE. Okay, LDPE has many branches. So when if you put another molecule of this close to there, there will be open space. Here will be open space. Here can be. So when we have this type of structure, that means LDPE, therefore there will be some open space which can hold some air, so that the density decrease. And for these types of structure, that can be little bit, it can come close together. So open space will be reduced, therefore density can be increased. Now, what is this LLDPE? No, I can. Just a second, maybe I have that. I have forget the name. No. Low level? No. Just I have forgotten instantly. Okay, that is not so very important. Later I can give you the information just when I can remember it. Yes, thank you. Linear low density polyethylene. Linear, that means this is linear, and low density, that means just this is not linear. Okay, you always expecting like this is not linear. Then how do you expect the propane molecule? This is carbon, and then this carbon, and this is it? Like this. And even if you want to write down butane, is it? Then we call this is linear. We don't call this is linear. Methane, propane, that means when you write down butane, N-butane. What does it mean? Sorry, butane. N-butane, normal butane, that means linear. When you write down these types of butane, this is cyclic. So cyclobutane. But this is N-butane, linear butane. So if you can consider this is linear, then why you cannot consider this is linear? Okay? But everything what we say, that is not the reality. If you may consider that linear equation, sometimes when you go for the research, maybe you can get some data like this. This is your axis. So we are getting some data like this. So like this, is it? But based on your experiment, sometimes you may guess this is a linear up to this, and then extend it. Is it? Sometimes you can have another line like this. That means somewhere it is maximum and then it is reducing again. So we can have different types of observation and we can have different types of conclusion. So this HDPE, many cosmetic bottles or whatever other containers can be prepared by HDPE. It is used for manufacturing toys, buckets, dustbins, then bottles, pipes, etc. Chemical containers, recycling bins, grocery bags. For different types of purpose, we can use the HDPE. Polyvinyl chloride, PVC. That means mostly the water pipes that are made of this PVC, and sometimes the door for the bathroom, because we have to use lot of water, and when we use the water, if we have the door made of wood, just within few years the door can be damaged. So most of the time we try to use the door made of PVC for the bathroom. So polyvinyl chloride is obtained by heating a water emulsion or mixer. Just we can use the mixer of vinyl chloride. Polyvinyl chloride is obtained by heating a water mixture of vinyl chloride. Anyone can write down the structure for vinyl chloride? Vinyl chloride. Okay. If you cannot, this is the vinyl chloride. So simple, is it? If I say this is 1 chloroethene, then you can say. But this is another name, common name or trivial name. So, or sometimes we call pet name. Pet name, is it? You may have, some of you may have the pet name. Just not the pet cat. Okay. So this is the vinyl chloride. That means only one chlorine is substituted for the ethene. Previous one, that was only ethylene. Now very similar, just one chlorine replaced by one hydrogen is replaced by chlorine. Okay, so if we have the many molecules of vinyl chloride in the presence of a small amount of benzoyl peroxide or hydrogen peroxide, so we can use the benzoyl peroxide or hydrogen peroxide into autoclave under pressure, at high pressure, normally high pressure. Then many molecules of vinyl chloride will combine together to form polyvinyl chloride with the presence of these types of free radical catalyst, benzoyl chloride or benzoyl peroxide or hydrogen peroxide. Vinyl chloride, so needed, is generally prepared by treating. Okay, so how you can synthesize this vinyl chloride? Hydrogen chloride, just very simple. Just if you can add vinyl chloride, so needed, is generally prepared by treating acetylene at 1 to 1.5 atmosphere with hydrogen chloride at 60 degrees to 70 degrees Celsius in the presence of metal chloride catalyst. So to study the vinyl chloride, we don't need to study this. Just this is extra information, because I guess all of you are familiar with this, how we can synthesize the vinyl chloride. Acetylene, and this is vinyl chloride. The reaction between acetylene and hydrogen chloride is giving the vinyl chloride. What are the properties for vinyl chloride, polyvinyl chloride? It occurs as a colorless rigid material. Normally, we can have different types of pipes or different types of doors or different colorful hard chair or any other things. In that case, we can change the color by using or adding some additives or colorants. Okay, it is having high density and low softening point. That means low softening point and high density. Just high density doesn't mean above 1. Just 0. Up to 0.96. That is our highest density for the plastics or polyethylene. It is resistant to light, atmospheric oxygen, inorganic acids, and alkalis. That means most of the time we can use these types of hard plastic or hard buckets to carry different types of chemicals or any other things, and it cannot survive to very high heat, but it can survive for different types of chemicals, inorganic acids and alkalis. So it can survive for the chemicals but not for heat, because only we have seen that softening point 148 degrees Celsius. If you go above this, then it can melt up. It is most widely used synthetic plastic. Okay, so synthetic plastics we can use for this one. What are the uses? It is mainly used as a cabin insulation, leather cloth, packing, and toys. So I think I don't need to read out this. If all of you can read much better than me. Okay, then we are going to, okay, this is our gloves. We can use this for the cooking. These types of, and these are plastic pipe, PVC pipe. These are some toys. Nylon 66. Okay, how we can synthesis and what are nylon 66? how we can synthesize this? Nylon 6,6 is synthesized by polycondensation. Just previous two, we have mentioned that can be synthesized by addition polymerization. Now we are going to learn about the condensation polymerization. In last class, we have mentioned that condensation means removal of mainly water or any other molecule also, just from two different components. Maybe we can remove hydrogen chloride or any other components also, but just removing some of the parts of the molecules. Okay. Nylon 6,6 is synthesized by polycondensation of hexamethylene diamine and adipic acid. This is our adipic acid and this is hexamethylene diamine. One amine, this is another amine. Two amine, so we call it diamine. So hexamethylene diamine and adipic acid. This is our adipic acid. So when these two chemicals react, then we get this is our nylon 6,6. And how it forms? Equivalent amounts of hexamethylene diamine and adipic acid are combined with water in a reactor. This is crystallized to make nylon salt. Okay, first when we add equivalent amount of the hexamethylene diamine and adipic acid, then it forms a salt. What salt? This is crystallized to make the nylon salt. And ammonium or carboxylate mixture, which is known as that. This is ammonia, diamine, and this is acid. So this can be act as a base. Amine, any amine is considered as base or alkali, whatever you can say, and this is directly acid, adipic acid. This is a carboxyl group. This is also another carboxyl group. So when we are reacting with an acid and alkali, definitely you can expect to form salt and water. Is it? Okay. So we are getting salt. First of all, the nylon salt goes into a reaction vessel where polymerization process takes place either in gases or continuously. That means once we get the salt, then it is taken into another vessel and it polymerizes. It can be performed in batch and continuously or continuously. What does it mean, batch or continuously? Have you any idea about this word? This is some industrial word, batch and continuous. Okay. If you are taking lot of chemicals and in single step, you are getting all the salts and then you are transferring all the chemicals into another container so that just there is nothing left and you have transferred all the chemicals into another container to get the product. That is batch process. That means until all the process is completed, we are not doing any other initial works, but continuous process, that means continuously this reaction is going on and then it is transferred to another pipe and then it is continuously making. So this is continuous process. Yes. So batch process, which is done individually, step by step, but continuous process, which is linked one by another. So it can be in continuous process, we can make lot of products at same time. And removing water drives the reaction toward polymerization. So when we are making the salt and water, because we have mentioned that this is a base and this is acid. So when the acid and base reacts, we are getting salt and water. So by removing that water, it try to make the polymer. Through the formation of amide bonds from the acid and amine functions, the molten nylon 6,6 is formed. Then these are the structure for the molecular structure of nylon versus nylon 6,6. This is the nylon 6,6 and this is nylon. So we will be interested on this. not this. What are the applications of nylon 66? If we have anything, no, this is metal. Yeah. Yes. Not the same thing. Okay, nylon 66 is frequently used when high mechanical strength, rigidity, good stability under heat or chemical resistance are required. If you need very high resistivity or very then mechanical strength, if you want to tie to heavy objects, then you can use the nylon rope. Very then good stability under heat. That means normally if you heat, it will not melt up within a very low temperature.
But then, I think the line broke that I mentioned, when we near the fire, it was.
Yeah, that is the nylon rope. What you are mentioning, that can be different quality also.
Oh,
So just some of them can melt very quickly. If you bring to the fire, then it can catch fire also.
yeah.
But some of them it can be used for very high temperature also. It is used in fibers for textiles and carpets and molded parts of the luggage, parts for luggage, airbags, apparel, and for carpet fibers. There are different types of use. Nylon 66 lends itself well to make 3D structural objects such as radiator end tanks, rocker covers, air intake manifolds, and oil pans, etc. And another very important application, other applications include electro-insulating elements, pipe, profile various machine parts, zip ties. All of you familiar with the zip ties? But in here, maybe I don't know about their laboratory, but outside our country, we have lot of jute in Bangladesh, is it? Therefore, so we don't need to use too many zip ties. But outside Bangladesh, very rare case, we have seen that people uses jute rope. But most of the time, we use some zip tie instantly. That is made of nylon and just tie very quickly. So
The zip that is sheet, that is.
no, not this. Zip tie. This is here is. This is the zip tie. This one. Okay. Now, oh, all of them are. This is also another one. This is zip tie. Okay. That is made of nylon 66. And polymer frame weapons and the outer layer of turnout blankets, nylon 66 also popular guitar nut material. Those one, which one is fixed? The guitar wires. If guitar wires are attached to some nut, so that you can tighten it or you can loosen it. So that the guitar nut material, that is also made of nylon 66. Phenolic resins or phenoplast. Bakelite, we will learn how we can synthesize the bakelite. It is prepared by condensing phenol with formaldehyde. Very simple. Just phenol. This is our phenol. So phenol with formaldehyde, or we can call methanol. Is it? So phenol reacting with formaldehyde, it can give two different types of products. The initial product could be a linear product, Novolac, used in paints. We can have this types of. If you can, this is our Novolac. So we can prepare phenol. Sorry, we can use phenol and formaldehyde to make the color used in paints, Novolac. And another one, we can have the result. We'll see what is this. Monomethylol, phenol carbon, formaldehyde reacting with this structure, then it combined to form. So that is the compound. What we can see, this is ortho, and then this is another position. Then three different groups here, one, and then here we can see. So this types of crystals, or sorry, this types of polymers we can make. Then on heating of Novolac above 150 degrees Celsius in the presence of hexamethyl, then methyl, okay, methylene tetramine, sorry, hexamethylene tetramine, sorry, hexamethylene tetramine in a mole produces highly cross-linked structure called as bakelite. So first, what we will get? We will get this compound, just phenol formaldehyde reacting with Novolac, and then if we heat above 150 degrees Celsius in the presence of hexamethylene tetramine in a mole produces highly cross-linked structure called as bakelite. Here you can see cross-linked. Link this one linked with this, and then another one. This is linked. So these are linked together. So highly cross-linked polymeric material, which is known as bakelite. What are the properties? Good chemical inertness. Normally it do not react with anything. Good resistance to water. So just it can prevent water. Shows good electrical insulating properties. Same thing, these two. What are the applications? It is used for making electric insulator parts like switches, plugs, switchboards. Can be this. Is it? For making molded articles like telephone parts, cabinet of radio and television. So we can have different types of things out of polymers. So in the first class, I have mentioned that we cannot think anything without polymer, or even we cannot think anything out of organic substances, or anything what we say, or what we eat, what we wear, or what we catch, what we see, everything made of different types of organic compounds, and that comes ultimately different types of polymers or hydrocarbons or whatever something. What we can use? Bakelite material of 1,000 uses. Clear bakelite items, then phenolic resin, celluloid cloth, bakelite telephone. But now this is not available, is it? Yeah, this is very rare. Then bakelite camera. So, and then radio. I have never seen these types. And then microphone. That is also not available nowadays. Oh, yeah. Epoxy resin. If you have some glass sheets. Sorry?
5 minutes break.
5 minutes break? We are almost done. Okay, Now we would like to learn about the resin, epoxy resin. So normally we call araldite or epon, but it's better to remember this resin. So first, it is prepared by condensation polymerization of bisphenol. Bisphenol A, this is a compound, bisphenol A, and epichlorohydrin. So this is bisphenol A, this is very big compound, and then epichlorohydrin reacting with this together. So this is our epichlorohydrin. And this is bisphenol A up to this OH. So when this hydrogen and chlorine is removing, so here you can see the condensation. As already I have mentioned that for condensation you don't need to always remove water. You can remove something else also. Here hydrogen and chlorine, these are removing. This is minus NHN. That means we are removing the HCl molecule, so that we call it the condensation polymerization. Here you can see the condensation polymerization. By this process, we can get the epoxy resin. This is very simple. Just two benzene ring, and this is one carbon, methyl, and hydroxyl. Just two N we have. That means this is phenol. Just consider phenol. This is another phenol, and this carbon and this two methyl. So this is our bisphenol A, and reacting with epichlorohydrin. So this is our epichlorohydrin, and then it's removing one HCl for each molecule. So N molecules, when it reacting N molecules, so this is N, this is N. So removing one HCl, sorry, N HCl, then we are getting the epoxy resin. So what are the uses and properties for this resin? Properties: epoxy resin, due to presence of very stable ether linkage. This is the ethers, is it? This is ether group, this is ether group. So we have very stable ether linkage. Therefore, high chemical resistance to water. So it do not come into contact with water. Just it do not make the hydrogen bond with water. That means when we put the dress or something like this, it absorbs water because it makes the hydrogen bond with water. But this resin, they do not form the hydrogen bond with water. Therefore, very stable ether linkers have high chemical resistance to water, good dimensional stability. So just you can keep in any shape and it will remain for a long period of time. So dimensional stability, excellent mechanical and electrical properties. Interesting thing, most of the time we have learned that all the polymers are different types of polymers are resistant to electricity or heat, but excellent mechanical and electrical properties. It has very good electrical property, good resistance to heat and chemicals. If you heat up, it do not melt easily, and it do not react with chemicals very often. High flexibility, just soft. You can keep, you can put in between the glasses. Just you can put the resin for long time, and it will attach with the glass, and very flexible. Just you can put in any shape. As surface coating, skid resistant surface for highways, then laminating material for electrical equipment, pressure vessels, protective coverings. There are different types of uses for epoxy resins. Now the rubber, but we have already familiar with the rubber. Natural rubber is prepared from latex of Heva rubber trees. This is the name of the tree. So naturally we get it. Have you ever been to the forest, Ramu forest? I think this is nearby Cox's Bazar. In that forest, we have lot of rubber tree. In Sylhet, no, it should, Ramu, Cox's Bazar, nearby, just in the Cox's Bazar district. Sylhet, okay, that can be. Okay. It is linear polymer of isoprene to methyl 1,3-butadiene is called polyisoprene. This is 1,4-polyisoprene. So this is isoprene. Anything to discuss with me? Excuse me. Do you have anything to discuss with us? Okay. You can discuss with us, because if you have something question or you want to explain, then you are welcome. No problem. So isoprene, we have these types of chemicals. That means methyl. This is one methyl group, and then two double bond. That means 1, 3, then methyl, 2 methyl, and then 1,3-butadiene. This is 2-methyl 1,3-butadiene is our isoprene. So when many molecules of isoprene combine together, then it forms polyisoprene, which is called as rubber. How the rubbers are prepared, you don't need to think about. Just remember this one would be enough. This is isoprene. This is very simple structure. Just one diamine, sorry, not diamine, containing two double bonds, alkene. That means 4 carbon containing alkene and 1 methyl group isoprene. So when it reacts, when it combines with many molecules, then we are getting the rubber or polyisoprene. So forget about this. Vulcanization of rubber. That means what types of characteristics you want from the rubber. Vulcanization of rubber is a process of improvement of the rubber elasticity and strength by heating it in the presence of sulfur. If you do not have sulfur, most of the time when you burn the rubber, you will get some smell of the sulfur, bad smell. Normally you get, even not only this, if the egg is rotten, then you can get some bad smell that comes of sulfur containing compound. So H2S, that is sulfur containing compound, is it? Okay. So vulcanization of rubber is the process of improvement of the rubber elasticity and strength by heating in the presence of sulfur. So to improve the quality of the rubber, we add sulfur, so that when you burn the rubber, you get the smell of sulfur or bad smell. The physical properties of rubber can be altered by vulcanization, just by adding the sulfur or some other chemicals. The low water absorption capacity than raw rubber. That means if you add the sulfur, that means vulcanization process. After vulcanization process, you can get the quality so that the low water absorption, it will not absorb too much water. Better electrical insulator. Just we can increase the insulating property of the rubber. Resistant to organic solvent, so that you can prepare, so you can use the hand gloves in the laboratory. That means that are also made of different types of rubber. The hand gloves in the laboratory. Vulcanization is the cross-linking of polymer chains with sulfur atoms by applying heat. Just if you heat in presence of sulfur, the natural rubber, then it can increase the cross-linking, so that here you can see this is not clear. However, here this is one sulfur, this is another sulfur, sulfur, sulfur. So it has the link with this ring. This is our chain. This is another chain. So within these two chains, it is making linking. Therefore, in that case, when any molecule has this types of cross linking, then it is become hard and it is very difficult to break. But if you do not have these types of link, just linear, it can slide one over another. So that can be easy to remove. Vulcanization increases the abrasion resistance. Useful temperature range increased. So normally, if you have natural rubber, then it can melt with very low temperature. But and also it can be used only certain range of temperature. Even not when I did some experiment, not experiment, just fun. I have used this type some rubber and put inside the nitrogen, liquid nitrogen. What happens? Can you imagine? No, it will become hard, very hard. And then if you throw into the floor, just it is break, completely breaks. So yeah, so just like as glass, it will be breaking down like glass. So first I put inside the nitrogen, liquid nitrogen, the temperature is very low, and then no, inside nitrogen it will not blast, just it will harden. Then it is hardening, and then when you throw in somewhere, then it decomposes. And conducting polymers, that means some polymers can help to conduct electricity. So we can also have that types of polymers. That are the range for insulator, conductor, or semiconductor. So, and there are something more, but I think that are not so important. Types of conducting polymers, that's fine, it is not the topic for organic, but we can skip. Okay, antimicrobial agents, that is not clear. Antimicrobial agents are suitable for modifying stent materials. The agent is solely released and preserves biofilm formation. So we can have some polymeric materials that it can help to protect the antibacterial capacity or bacteria, to protect the bacteria. So that can be helpful. So that is little bit more complicated process, but we are not going to learn in this course. So I think this is the end for this chapter and for today. Thank you very much. If you have any question or comment, then you are welcome.